So here it is a little bit more vocabulary with circles, okay? So two circles are considered congruent if and only if they have congruent radii. So remember, if and only if is an example of a biconditional statement. Okay, so recall from the first semester that a biconditional statement is where the conditional statement and its converse both have to be true. Okay, so let's look at this biconditional statement here. Okay, so it says that circle A is congruent to circle B if segment AC is congruent to segment BD, right? So basically we're saying this radius AC has to be the same length as this radius BD, okay? Conversely, segment AC is congruent to segment BD if circle A is congruent to circle B, okay? And so again, it works both for the conditional statement and its converse, okay? Moving on, concentric circles. Okay, again, make sure you get these in your notes. Concentric circles are coplanar circles, meaning, again, they're on like the same sheet of paper, okay, not a piece of paper that's above the other one or below the other one, okay? Concentric circles are coplanar circles with the same center. So you can see that the red circle and the blue circle have the same center, so they're considered concentric circles, okay? And then finally, we have what tangent circles are. Okay, so tangent circles are two coplanar circles that intersect at exactly one point. And we have a couple examples here. Okay? We have internally tangent circles where one circle is inside of the other circle. Okay, notice they have a point of tangency right here. Okay, and we have another case, again, where these two circles are outside of each other. Right? So again, these two circles are outside of each other, but they do intersect at this one point of tangency. So these are considered externally tangent circles. Okay? So moving on, okay, it says we want to find the length of each radius. Okay? So that's the first thing we want to do, find the length of each radius. They also want us to identify the point of tangency. And then they want us to write the equation of the tangent line at this point. Okay, so let's take care of the first things first here. Okay, so the radius of circle S, okay, it looks like it's about, we'll just go either, again, straight left to right or straight up and down. All right, and this looks like it's going to be about 1/2 here to this next grid line, and then 1. So it looks like the radius, I'll say radius of circle S equals, I'll call it 1.5. And it looks like for R, again, we can go left to right on this one if we want to, because it is kind of on the corners of the grid lines there. Looks like we go 1, 2 until we reach the outside of the circle. So I'll say the radius of circle R equals 2. Okay, now the next thing we wanted to do was identify the point of tangency. Okay, or where's the one common point that these circles have? And we can see it's actually right here. Okay, where those two circles or the outsides of those circles actually cross. Okay, and so again, it looks like it's going to be the point -2 and 0. Okay, so the point of tangency here is going to be -2 and 0. I'll say is point of tangency. Okay, and if we actually wanted to draw a line on this part that represents the point of tangency, it would be this purple line right here. Okay, and again, we can just use a couple points on this purple line and actually write the equation of this. I'll just use these ones. Okay, so it looks like we have maybe the point -1 and 0, and also the point 1 and 0. Okay, and we notice from the warm-up, okay, remember that these actually match here. Okay, these y values of our ordered pairs actually match. So our actual answer for this is just going to be y equals 0, okay? And let's just say, is the tangent, we'll call it the tangent equation. All right, so let's look at one more quick example, okay? I think this is fairly simple, right? So it says find the length of each radius, okay? Again, maybe I'll just do this again. Find the length of each radius. Then we want to identify the point of tangency, and then we want to write the equation of the tangent line at this point. Okay, so let's start with, again, finding the length of each radius. So circle D, looks like it's 1, 2, 3. Okay, so let's say radius of circle D equals 3. Okay, and we'll say radius of circle C is, looks like it's just 1. Okay, so really pretty easy there. Okay, identifying the point of tangency, again, it's that one point that these two circles have in common. It looks like it's the point 2, -1. Oops. Okay, and then finally the equation for this is just going to be the equation of this line here, right? This line that goes through that point of tangency. Okay, and so again, I'll just pick 2 random points on this line. Okay, and it looks like we'll call that 0, -1. And the other one, we'll call it 2 and -1. So again, these are the ones that match. So this is going to be the equation of our line. Okay, so we're going to say that the equation of our line, or our tangent line to these two circles is going to be y equals -1.